Section 4.3 is about mixture problems. So mixture problems, sometimes they're used in like a chemistry course or science course, and they're one of the most common applications of systems of equations. And they're not too bad. They can be kind of tricky, but it's just important to organize the information. So it says a chemist needs to mix a 12% acid solution with a 20% acid solution to obtain 160 ounces of a 15% acid solution. How many ounces of each of the acid solutions must be used? So we have a lot of information. We're mixing a 12% with a 20% to obtain a 15%, and it's specifically 160 ounces of that. And again, the last sentence always tells us, or usually tells us, what we're trying to find. So how many ounces of each must be used. So that's what I want to define my variables to be. So I'm going to let x be the ounces of the 12% solution, and I'm going to let y be the ounces of the 20% solution. Okay, so I need to make two different equations. So you always need to have two equations when you're solving a system of equations, otherwise you can't solve for it. So I want to make an ounce equation, and then my other equation is actually going to be percent times ounces. And I'll explain that. So the ounce equation, well, x is the ounces of the 12%, y is the ounces of the 20%. I don't know how much of the x there'll be, how much of the y there'll be. That's what they're asking. But I know if together, if I add them up, then that has to be 160, because they say that I need 160 ounces. Now for the second equation, it's percent times ounces. So x is the ounces, the percent of the x solution is 12%, so that's going to be 0.12 times x, plus y is the amount of ounces in the 20% solution, so that is the 20% solution, so you need to take 0.20 times y. And then the last part is the trickiest part. We are trying to get the 15% solution. That is our goal. But I can't just put 0.15, because here I'm multiplying the percent times x, and x was the amount of ounces. Here I'm multiplying 20% times y, y was the amount of ounces. Here I need to be multiplying a percent times the amount of ounces, and my amount of ounces is 160, because they want us to obtain 160. So it's going to be 0.15 times 160, and that is equal to 24. So that is very tricky. Very tricky. So my actual two equations are x plus y is equal to 160, and 0.12x plus 0.20y is equal to 24. Okay, so I'm going to choose to solve this by elimination. If you wanted to use one of the other methods, then you could. And I want to get rid of the x's. So there is a 0.12x here, which means I want a negative 0.12x right here. So I'm going to multiply by negative 0.12 to the entire equation. So that's going to give me negative 0.12x minus 0.12y is equal to negative 19.2, and the second equation remains unchanged, and I want to add these up. The x's go away, just like I wanted. The y's become 0.08, y is equal to, and then negative 19.2 plus 24 is 4.8. And then if you divide both sides by 0.08, you get y is equal to 60. And that is ounces of the 20% solution. So then to get the x, if you just look at the original equation, x plus y is equal to 160, x plus 60 is equal to 160, which means if you subtract 60, x is going to be equal to 100. So that's 100 ounces of the 12% solution. And that'll be your answer.